Hey Taylor, so this is the problem I have for you, and we're going to call this right here our A sub n. Okay, so A sub n is what they give us, and then we need to come up with something to compare it to, but something simpler for our B sub n. Now we want our B sub n to be greater than our A sub n, but we want to use pretty much the same thing. Well, I'm just going to say, well, the smaller the denominator is, the bigger the overall fraction is. So a b sub n could be, well, if I took away that 2 plus right there, and I made it just 1 over square root of n. Okay, well, this right here is going to give me very similar, for every time I plug a number in for square root of n, the only difference is this is just going to add 2 to the denominator, okay, which makes the overall number just a little bit smaller than this one. So I know that this is going to give me a value just a little bit larger than this one. But most importantly, they're all going to be greater than 0. So nothing that I plug in for n from 1 to infinity is going to give me 0 or less than 0. Okay, that's super important. So here's my B sub n. Okay. Now I used limit comparison test that said we do the limit as n approaches infinity of a sub n over b sub n. And we want that to be equal a c value that's greater than 0. If that happens, they're either both divergent or both convergent. Now, another reason I picked this one is I could rewrite that as 1 over n to the 1/2. And you may have seen it look like this. All right, it's called your p-series, where if I have 1 over p to the n, if n is greater than 1, then it's convergent. If n is less than or equal to 1, it's divergent. Okay, well here I have 1/2, which is less than 1, so I know this is divergent. So if I can prove, or if I can plug in here and get this right here to give me a value, and not only just a value, but a value that's greater than 0, then I can say that both of these, by my limit comparison test, have to be either both divergent or both convergent. And since I already know that this one is divergent, then I can say this one also has to be divergent. So let's do that. So I'm going to say, all right, well, my a sub n goes on top, 1 over 2 plus square root of n over 1 over square root of n. Normally, I would multiply top and bottom by the reciprocal of this. All right, but I really want to get actually a fraction of n's. That's going to simplify a little better. So I'm going to multiply top and bottom by 2 plus square root of n. 2 plus square root of n. Okay, so if I do that, those two cancel out. I end up with a 1 on top. On the bottom, I have 2 plus square root of n over square root of n. Well, I can break this into 2 different fractions and say this is 1 over 2 over square root of n plus square root of n over square root of n. And then I can say, well, those two is just 1, so 1 over 2 over square root of n plus 1. Now, again, I should have kept that whole limit. Sorry, this is all the limit as n approaches infinity. So I should have had the limit as n approaches infinity in front of all of these. Okay. So at this point in time, I'm actually going to plug infinity in. Okay? Well, when I take the square root of infinity, it's still approaching infinity. And whenever I have a constant over infinity, so constant over infinity, that always equals 0. So this right here is just going to be 0 plus 1. 0 plus 1 is 1. 1 over 1 is 1. And so since I got a value, and not only just a value, but I got a value greater than 0, I know that both of these have to be either convergent or divergent. And since I know that this one is divergent, things, I know this one also has to be divergent.